Here we go, we have a question rotate array. So you have given an unsorted array and we need to rotate the array to the left, means counterclockwise direction, by d steps, where d is a positive integer and we need to do the mention change in the array in place. The note here is consider the array as circular. So in this we need to do the rotation by two times. So first this one will come forward, then this two will come forward. So this is the output after rotating two times. And in this example we need to do the rotation three times. First this 2 will come ahead, 3, then 6. So we got this array by rotating 3 times. So in this we need to do the rotation by 9 times. First this 7 will come ahead, then 3, then 9, then 1. So we got the same answer then after rotating 4 times. So if I do the rotation 4 more times, we got the same answer. Then only one time remain. We put this 7 to the front. So we got this as the output answer. So let's try to build the approach. So we have this example and this is the expected output. So first let's talk about the uh, naive approach. The naive approach will be to use a separate array of n size, and these first two elements, we have these first two elements will be here and the remaining elements will be in front. So what you can do, you can start a loop from k, you can start a loop from k till n minus 1 and first fill the indexes, and for the last remaining indexes you can start a loop from 0. So this will be the naive approach. And one optimization I want to talk about is, let's suppose we have this example, we have this case and we need to do the rotation by 5 times. So first this one will come ahead, then this two. So let's take this example, and first this one will come ahead, then this two will come ahead, 3 will come ahead, then 4, then 5. So we got the same output as our input array if I do the rotation by 5 times. Then if I do the rotation by 5 more times, then we also got the same answer. Why? Because length is 5 itself and we are rotating 5 times. So let's suppose we need to do the rotation by 6 times. After the 5 times we got the same answer and we just need to do the rotation by one more time. So one optimization you can do is, you can take modulus with n value. So this is the optimization that we can do. And let's talk about how we can solve this question in a most optimal manner. So first we have this example. In this we want to create this array. So what we can do is, first let's rotate this array itself, this sub array itself. So after rotating this sub array we got this, and let's reverse this array individually. So we got 5, 4, 3. So can you relate this subarray, can you relate this subarray to our answer? Yes, if you can carefully observe, this is the reverse answer. This is the reverse answer. So if you do the reversal on this, we got 3, 4, 5, 1 and 2. So this is our output answer. So first what we need to do, we need to do the reversal from 0 to k minus 1, which will reverse this array, and then we need to do the reversal starting from k till n minus 1. So this will reverse this array, and after we got this we just need to do one more reversal on the whole array, means 0 to n minus 1. So we got this. So let's prove it on this example. So we have n as d, you can say we have d as 3. So let's rotate first this array. 6, 4 and 2, and let's rotate the other half of the array. We got 20, 18, 16, 14, 12, 10 and 8. And now let's rotate the rotate this array. So first we got 8, then 10, then 12, 14, 18, 14, 16, I missed 16, then we got 18, then we got 20, then 2, then 4, then 6, then 6. So this is the output array. Means first we put 2 ahead, then we put 4 ahead, and then we put 6 ahead. So this is the reversal. This is the reversal that we want. So this is the left reversal. Why this will work? Because the shifting takes place on this subarray and this subarray, on this subarray and this subarray. So the rotation will be done. If I rotate, if I rotate first half of the array, and if I rotate the second half of the array, second half of the array, then the element the element here the element here will go on the last position, and this element will come in the front position, in the front position. And this element this element, if I do the reversal, we got on the first position, and here we got on the last position. So that's the reversal, that's the output answer that we need. So let's talk about this test case. In this, let's say 4, we have length as 4, and then 4, so we need to do the reversal 9 times. So if I take mode with n is the length, we got 1, so we just need to do the reversal one time, so 7 will come ahead. So what we'll do is, first we reverse this array, and then we reverse this array. Then we know if the element on the first half will shift, the just next element will come on the front side. So this element will come on the front side, and then we got 7. So as you can see, we just done one operation, and this 7 will come ahead. So that's how this approach will work. So let's code this. Code is very simple. We need to do the reversal on the input array itself, means in place. So first find n and take the modulus, then reversal from 0 to d minus 1, then on the second half, then on the whole array. So this is the reversal function. I hope you are already familiar with the reversal function. Then let's submit this. If you are not familiar with the reversal function, I will attach a video in the I button. So be sure to check out that video first. And let's talk about time and space complexity. In this, the time complexity will be order of n, and the space complexity is constant. So let's find out. Yes, we have met the expected time and space complexity. If you guys have any doubt, feel free to ask in the comment section. Code is given in the description box. Thank you all for watching.